Hello everyone. Welcome to the DI 101 webinar series. My name is Jared Evans and I manage all the marketing efforts for Distribution International. This webinar series is an incredible resource offered to DI customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars deliver informative presentations about industry trends, new technology, new products, and product applications. We are extremely excited to welcome our strategic manufacturing partner, ITW, for today's webinar presentation discussing commercial building chilled water applications. Presenting today is Heather Sharif, Technical Advisor for ITW. Heather has been with ITW for more than 2 years. Prior to that, she worked for Baker Hughes for about 8 years. As Technical Advisor for ITW, she assists customers with everything technical, from installation guidelines, review specifications, interpretation of code, and performing a wide variety of calculations. She also participates in industry organizations such as ASTM, ASHRAE, IIAR, and NIA. We are proud to have Heather and ITW present today, and we certainly thank them for their time. We will pause for questions at the halfway point of the webinar and then again at the end. To submit your questions, please use the Questions tab on the GoToWebinar control panel. You can submit your questions at any point during the webinar, and we will answer the questions during those 2 question periods. Without further delay, I will turn this over to Heather with ITW. Thanks, Heather.
Thank you very much. So we are going to be talking about the commercial building chilled water application. We're going to be talking about applications for Trymer PIR, our Trymer 2550, Supercel Phenolic, Saranex, and metal jacketing. We're going to be covering key properties of the Trymer products along with the Saranex film and tape. We'll move on to talking about the effects of water on an insulation system. We'll then get into some of the USA codes for chilled water pipe insulation, along with some commercial building applications. We'll then discuss some of the differences between the insulation types, why you should use Trymer 2000, Trymer 2550, and Saranex on the commercial building chilled water pipes, where each of these should be used, and we'll also briefly mention corrosion under insulation. And then lastly is going to be the ITW added value, and this is a quick snippet of what it is I can provide. So when we look at Trymer 2000 XP, which we'll consider for this presentation the Trymer PIR, and the Trymer 2550, here's the list of the key properties that we find to be valuable. It's got a very good or low thermal efficiency. It's closed cell in nature and non-fibrous. It's got a good water resistance, both liquid and vapor. It's dimensionally stable. There's an ease of both fabrication and installation. It's got a long service life. The Trymer PIR has a good flame and smoke performance, and I will get into the Trymer 2550 a little bit different later. And then it is also lower in cost. So of all of these attributes, the 3 that we find to be of the most importance are going to be the low thermal conductivity, the good water resistance, and also the cost compared to other insulation property types. Keep in mind that Trymer PIR is not a polyurethane, although some might refer to it as a urethane. The polyurethane has the same basic raw materials as Trymer PIR does, but chemically it's reacted in a very different manner. So PIR is going to have a better performance and in many other important properties than a true polyurethane or even a true urethane. Some of the Trymer differences, they have similar performances other than the flame spread smoke developed ratings. So we've got a temperature limit of -297 up to 300 Fahrenheit. The physical properties, so the strength, the K factor, the water resistance, are all similar. The thermoset polymers, so they're not going to melt, and they will not be softened by solvents. And they also are fully compliant with the ASTM standard, which is C591, grade 2, type 4. For Trymer 2550 PIR, we consider the ratings to be excellent. So the flame smoke rating we said was the only one that was different, and that says it in its name. It's got a 2550 flame spread smoke developed indices up to 1.5 inches. And typically when used in commercial buildings, in air plenums, where the 2550 flame smoke is required by building codes, our PIR meets that specification. Trymer 2000 XP, which is our workhorse, still has a very good flame smoke rating. It's a 25450 indices, and it can be used in non-plenum areas of commercial buildings and also used both on outdoor and industrial applications. So next we're going to talk about the Saranex CX film key properties. So the permeance surpasses some of the strictest industry standards for each of the application ranges. It's strong and durable, it's resilient, and it's an attractive film if you were to see it, as long as it's applied correctly. The Saranex 540 CX is used for most chilled water applications, and then the Saranex 560 CX when higher strength is desired. It also has an excellent flame and smoke performance and meets that 2550 rating. The installation flexibility, whether it's field applied or factory applied, is good. It also has a good chemical resistance. It's got an abrasion resistance, and it can be used without jacketing if you're indoors. So it kind of matches performances of PVC. You do also want to make sure if you are using it indoors that it's in an area that's not going to see any abuse. It can also be exposed up to weather for up to about 14 days. So this can be beneficial if you're needing to start your system up earlier. For the Saranex CX Tape, so this is kind of the matching product. You've got the film and then the tape. This is going to be used on installations where you've got any elbows, fittings, or butt joints. The permeance is excellent. It's going to be the same as the base film. It's got excellent adhesion. There's no release paper on the back of it, and it can be used for patchability. It comes in a big roll like a duct tape or masking tape would. It's got a wide temperature range, and also, once again, the excellent flame smoke performance meeting that 2550. Like I mentioned several times, it's flexible, so it can conform to the elbows and fittings. The adhesive tapes for the easy installation for butt joints, typically you can use either the 520 or the 560 CX tape directly from the roll. Once again, it's got no release paper. For fittings and elbows, you're going to spiral wrap typically the 520. Things like this are laid out in our installation guidelines. The reason we suggest spiral wrap over 50% is so that if you're using a 520 and you need to match the 540 permeance of the film, you're able to do that because 20 plus 20 is 40. So you're getting the permeance that's required simply by spiral wrapping that Saranex 520. Fast and simple installation, and once again, because of that, it's going to have a low installation cost. So here's an application of the Saranex CX film to the insulation. You can see on the outside that it's got just one self-sealing tape. So you simply wrap in this case, the blue foam over the pipe, and then you would peel off the backing and then strap down that tape right there. You want to make sure when you're doing that it's also in an area that's going to be shedding water. So you want to make sure that that is in the 3 o'clock position facing down or in the clockwise position. Here's another application of the Saranex CX tape for the butt joints. So you can see that it's closed now and you're meeting up 2 parts. You would simply be able to wrap the vapor retarder tape around that butt joint. Once again, here's another visual of what it looks like for fittings and valves. You can see on this far end over here that it's been wrapped and looks pretty decent for being spiral wrapped. And then the same over here below this gentleman's hands. He's able to spiral wrap what he needs to make sure he's got the proper overlap and therefore the best sealing possible. So vapor retarder product tips. Especially for chilled water, we tend to want to avoid any aluminum foil-based products. They have that very thin aluminum layer, and that foil is kind of prone to damage and paper backing tears. So once again, if you've got paper, that's just going to support any mold growth if water was to get into the system, which would then just prevent or cause more damage. We also want to avoid using PVC as a vapor retarder. PVC is a jacketing that should be only used indoors and is not acceptable as a vapor retarder. You want to make sure that you are looking at the permeance of the vapor retarder, not the permeability. Those are two different requirements. The permeance needs to meet the design requirements from ASTM C755. It's not needed for service temperatures above ambient. A vapor retarder is not needed. And general guidelines is in refrigeration is that the permeance is measured at less than or equal to 0.02. Some other desirable properties you will probably want to consider would be puncture, abrasion, and tear resistance. Obviously, this flame smoke performance, tensile strength, color and appearance if it's going to be not covered by another jacketing, and then cost. So let's move on to the effects of water on the insulation system. Everybody knows or should know, and if they don't, I'm about to tell you, that water is the enemy of any insulation system, especially for cold systems. The humid air plus a cold pipe means that you have a driving force for the water and the water vapor to want to enter into the insulation. Water from that air is going to condense and possibly freeze on the cold pipe surface, as well as within the insulation. Moisture in chilled water systems, even in indoors, can cause major problems. Water or ice has a K factor, which is the thermal conductivity, that is 10 to 100 times worse than insulation material. And wet insulation has a very poor or even worse thermal conductivity. So any wet insulation and surfaces are obviously going to just make an environment that's more conducive for the growth of mold and mildew. Moisture is one of the requirements for mold to grow. Any paper-based vapor retarders are particularly bad because paper absorbs water, it then sits, never dries out, and forms mold and mildew. Water at the pipe or the tank surfaces is what's necessary for corrosion. As the moisture penetrates into the insulation, it starts condensing and it finds its way to the surface of the pipe. It's then going to be the contact of water with the pipe surface, which is going to initiate the corrosion process, which is that CUI, the corrosion under insulation. It's a big issue, especially in cold, hot cycling surfaces. And then the accumulation of water within the insulation system often is going to require some major maintenance and repairs. So as we continue to talk about the effects of water on an insulation system, I've posted 3 different pictures here. You can see that saturated glass fiber insulation with an ASJ causes concern with the mold and mildew growth, and that's what these are showing. The far right picture is the same. Most of this is all of fiberglass insulation, but the effects of the moisture penetration into and on the system can be seen just in these 3 different pictures. So we've talked about the effects of water on the system. We've talked about the Trymer 2000 XP, the Trymer 2550, and the Saranex products, which can help keep moisture and water out of the system. So when we talk about preventing moisture damage, the main point we want to make sure is that you want to keep the water and the water vapor out of the system. The best way to do that is to use a low permeance vapor retarder, in our case, the Saranex CX. You also want to make sure that your insulation is closed cell and has the low permeability and low water absorption. So any of our products, the Trymer PIR, the Trymer 2550, or the Trymer Supercel meet all of those. And we'll talk about the Trymer Supercel Phenolic in a little while. Many organizations have recommended against using open cell or fibrous insulation products in cold pipe applications. That includes IIAR, ASHRAE, the Army Corps of Engineers, the Federal Bureau of Prisons, and also Veterans Administrations. You want to make sure that you're also designing and installing a high quality insulation system. That comes down to the insulation itself, the vapor retarder, any sealants that might be used, and then the protective jacketing. So why use our products in chilled water? Well, the first and foremost is that they're closed cell and non-fibrous. All of our insulations have a good resistance to water vapor, so they've got the low permeability values. Both Trymer PIR, and this would include Trymer 2000 XP, 2550, and then our Trymer Supercel, all have a permeability that's less than 4 perms per inch. The insulations also have the low water absorption. Trymer PIRs are anywhere between 0.2 to 0.7%, and that's in a 24-hour immersion test. And then our Trymer Supercel is at 0.5% with a 2-hour immersion. So why use the Saranex film and tape? One, it meets all of the permeance requires in various standards such as ASTM, ASHRAE, and IIAR. Our 540 has a less than or equal to 0.02 perms, and the Saranex 560 is less than or equal to 0.01 perms. You don't have a thin, delicate foil layer. There's no paper. It's easily handled. The factory applied works just as well as field applying. And then the tape, the coordinating tape, offers ideal solutions for elbows and fittings. So glass fiber is widely used in chilled water applications, but we consider it to be a bad choice because it's got no resistance to water vapor. It's a paper surface, it's got the thin foil layer, so you're going to experience mold growth on the exterior. You're then going to end up with wet fiberglass, and therefore the insulating ability of it is going to just decrease. Okay, so let's move on to talking about flammability and the building codes for chilled water pipe insulation. Flammability of the pipe insulation in commercial buildings is typically governed in the US by what's IMC, so the International Mechanical Code, and it's then been adopted by the local jurisdictions. Commercial buildings examples are schools, museums, any tall buildings, condos, offices, hospitals, government buildings. The flammability requirements for the flame spread and smoke developed per ASTM E84, and those are going to be the 2550, as we have mentioned several times. One key note to differentiate between our Trymer 2000 XP PIR and then our Trymer 2550, we said that they're very similar, so why do two different products that are so similar? The reason is because if you are requiring that building code and it's required to have the 2550 rating, previously to us having Trymer 2550, you would have to move into our Supercel Phenolic, which is a much more costly endeavor than just being able to use our Trymer PIR. So we were able to come up with a Trymer 2550, which can be used in plenums where it's required. So when we look at what a plenum is, Per the IMC manual that we talked about, a plenum is defined as an enclosed portion of the building structure other than occupiable space being conditioned that is designed to allow air movement and thereby serve as part of an air distribution system. So you can see in the first picture, which is in yellow, that that is a plenum. So you see the forced air supply in, and then air comes out into all of this extra space. So not a plenum is the areas in blue in the bottom picture. It's dead space, nothing is circulating. So you've got forced air in and then a forced air return and a drop ceiling. So examples of this would be a living or working space of a commercial building. Hospitals are almost always fully ducted so that they can minimize germs. So when we talk about the IMC requirements for flammability of the pipe, like I've mentioned, in section 1204.1 of the IMC, you can see here, I will not read this verbatim, but it needs to be tested in accordance with ASTM E84, and it needs to have the flame spread index of 25 maximum and a smoke developed index not exceeding 450. So the key point here is that pipe insulation not in an air plenum is 25-450, and that's going to often be referred to as a class A or a class 1, and that would be our Trymer 2000 XP. Now, if you go to section 602.2.1 on materials exposed within a plenum, it once again states that it needs to be in accordance with ASTM E84 test, and that in an air plenum, it must have the flame smoke indices of less than or equal to 2550. So IMC only requires pipe insulation to meet that 2550 when it's located inside a plenum. Pipe insulation outside of a plenum can meet the 25-450. Trymer PIR meets the 25-450, as I stated, for any non-portions of the building. And typically 80% of pipe insulation is not located in a plenum. For the plenum areas where you need the 2550, you have two choices. You can use our Trymer 2550 up to 1.5 inches thickness, or if it's going to be above 1.5 inches thickness, our Trymer Supercel Phenolic. If you're not sure which you can use or what your thickness is, that is something that I can help you with, and I'll talk about that a little bit later. Pipe insulation installed outdoors or in industrial facilities typically doesn't conform to these flammability requirements of IMC. So why using chilled water? So some product recommendations based on codes and performance. For commercial buildings in plenums, you would want to use our Trymer Phenolic or our Trymer 2550. In non-plenums, our Trymer, any of our other Trymer PIR, typically our Trymer 2000 XP is going to be the best choice. Outdoors, like I said, codes typically don't apply. The flame spread is going to be governed by the job specification. If you're not sure if it's in the job spec or you want it to be in the job spec, once again, reviewing specifications and updating them is part of my job responsibilities, and I'd be happy to help you with that. Trymer PIR for the outdoor is almost always going to be your best choice. In all cold applications, the Saranex vapor retarder for commercial chilled water is going to be the 540, and then for anything colder, so less than 0 Fahrenheit applications, you would want to use the 560. So all of our products have the good flammability values. The Supercel Phenolic, I mentioned the Trymer 2550 goes up to 1.5 inches with that rating. Our Supercel Phenolic goes up to 3 inches thick. The likelihood that you would need 3 inches thick is not very often. So we meet all of the codes that are necessary for the commercial buildings. We also meet energy code requirements at thinner thicknesses compared to other insulations. We've got the good and excellent K factors. So PIR has the 0.19 thermal conductivity, the K factor, and Supercel Phenolic has 0.15, and those are both aged. We also yield lower thicknesses because of our low K factors. So it's going to help minimize insulation costs. It's going to help minimize the cost of any other components, because if you need less insulation, you need less vapor retarder, you need less jacketing, you need less banding, et cetera, et cetera. It also is going to allow for installation in tighter areas, because you're going to need less. And then easier compliance to any energy codes that come out. We're good and low in density, which is also going to possibly have an effect on the design of any structural supports. So any saddles or hangers. We're rigid and strong. We're CFC and HCFC free. And we also have a long history of successful use in not only chilled water, but refrigeration, LNG as well. We've talked about water a lot, so we've got much better water and water vapor resistance than fiberglass with the ASJ. We're going to have less wet insulation, but also therefore less mold growth. We're going to have a better long-term performance, a better insulating ability, and then the thickness reduction that we spoke about earlier. Compared to elastomeric rubber, we have a better water and water vapor resistance. The rubber would work if you used a vapor retarder, but typically that's not a combination that we see. We're also easy to fabricate. ITW is the manufacturer of large bun stocks, and then we're able to send it to our wonderful fabricators and distributors, and they're the ones who cut it into the shapes such as you see here in the pictures. So the ease of fabrication of being able to cut it into the shape that you need means that you're going to be able to get a tighter fit, both on elbows, fittings, valves, and as you can see here, the installations look pretty good. Trymer PIR and Phenolic with the Saranex vapor retarder has a much lower cost overall than a cell glass system. This graph on the left shows the thickness for condensation control. This is taken specific for a very specific set of design specifications. We use the algorithm that comes out of ASTM C680. I believe is what it is, but you can see here that the cell glass on this system would need 2 inches, whereas the Trymer 2000, you would need only 1 inch. So you're cutting off at least a half of your thickness by moving to using a PIR. As far as moisture vapor permeability, this shows the same thing. It's hard to see these lines, but this 4.0 red is the Trymer 2000 and the Trymer 2550. And then the cell glass, you can see, has a little way lower at 0.005, whereas fiberglass is up at a 110 permeability, which is the perms per inch, and then mineral wool is right up there as well. So we're pretty competitive when it comes to cell glass, elastomeric rubber, and our Trymer 2550 and 2000 products. So Trymer Supercel Phenolic, I haven't touched much on, because for chilled water, in plenums, you can either use our Trymer 2000 or our Trymer 2550 and save yourself some money. But I do want to cover the key properties of a Supercel Phenolic should you need more than 1.5 inches. It's got excellent thermal efficiency. It's once again closed cell and non-fibrous. It's got good water resistance. It's got a long service life with an ease of installation and fabrication. It's got fantastic flame and smoke performance, as we've discussed. It's dimensionally stable, and it does have a low cost per R value. So some of the differences between our insulation, the application range. For Trymer, it's -297 up to 300, whereas for Trymer Supercel, it's looking at -290 to only 250. The fire properties, as we've talked about several times, the Supercel Phenolic is fantastic and it's not going to melt. It can be used in plenums. The Trymer 2550 is also fantastic and will not melt. Once again, you can use it in plenums and or non-plenum areas. It can be used outdoors and on industrial applications. And then you've got our Trymer PIR, which has the good fire properties. And again, it's not going to melt. None of these should melt. This is mainly going to be used in non-plenum areas and the outdoor and industrial applications. So applications for the Supercel Phenolic or the Trymer 2550, mainly it's going to be the commercial buildings located inside the air plenums, as I have said. It's going to replace mineral wool or glass fiber. Both of our Trymer products have a lower cost per R value, and both the Trymer Saranex systems have a better water resistance. It should also replace cell glass. The Trymer products have, once again, a much lower cost per R value than cell glass, and you're going to have a huge reduction in thickness, which I've stated, and the system, Trymer Saranex system, is going to have great performance. So will Trymer Supercel be replaced by the Trymer 2550? No, that's not our intent. And not our best approach. The cost per R value of the Trymer PIR is superior than Supercel Phenolic, but we realize that in some cases you might need more than 1.5 inches thick. So we're going to recommend that you use the Trymer PIR with the 540 in non-plenums and use Supercel Phenolic and or the 2550 with the 540 in the plenum areas. You can use the above systems to replace the glass fiber, the cell glass, and the rubber in most commercial buildings. This next chart here shows just some product comparisons between the Trymer PIR and the Supercel. I'm not going to go through it. The 1+ is good, the 3+ is the best. So you can see that the Supercel and obviously the Trymer 2550 for the flammability is going to be wonderful. Supercel has an amazing K factor, while the Trymer PIR has an amazing cost per R value. So you can see kind of those ranges here on this product comparison chart. And then lastly, this is a quick blip at what I have the privilege of doing every day. Design calculations. These can include insulation thickness calculations, heat gains or losses, condensation control. I can provide thickness tables with various conditions for you. I work with time to freeze, saddle hanger calculations, including spacing. I then also work on the insulation system design. So any guidelines that you find on our website, I'm in charge of keeping those up to date as possible. I also help with any system troubleshooting. I review proposed specifications to make sure that they're up to date. Any extensive literature that you see online, any letters that might be written that you need, any assistance with medical code or mechanical codes and questions, I'm also the person to help with that. So to quickly summarize what we consider to be the ITW difference, we're going to have superior products with the Trymer PIR, the Supercel, and also our XPS as well. Our Saranex CX films and tapes, and then our metal jacketing and 2-piece elbows. We've got superior service, both technical and commercial help, and we have a very thorough website. So we will now stop and see if there are any more questions, and if not, I have put both my office number and my email on the screen, and I'll leave that up there for a few minutes for those of you who need to write them down. Feel free to write them down. If you come up questions later, you're more than welcome to contact me. Jared, I'll hand it back over to you.
I just want to thank Heather with ITW Technical Advisor for them. And what these webinars really try to do, we have a lot of great manufacturing partners that make a lot of great products. And what these webinars are meant to do is to help our customers and our associates know more about those products and the applications of those products and give tips for installation and things like that. And I think Heather did a great job of that today, so thank you. We do have a few questions that came through. So let's see, the first one says, this is a customer asking if a customer doesn't really care for the look of the spiral wrap tape, what other finish options are there for fitting?
If you're going to be leaving the Saranex vapor retarder exposed and not be covering that up with any sort of jacketing, unfortunately for elbows, valves, anything that is not of a straight nature, you're not really going to have any other real option besides the spiral wrap. The reason we say to do the spiral wrap and the reason we tell you that it needs to happen is because we want to make sure that you have a continuous vapor retarder throughout the entire system. That's going to lessen the chances of water vapor getting into your system. So leaving it off would also not be an option. I think your other choice would be to cover it with PVC jacketing if it's indoors, or metal jacketing if it's outdoors.
Great, thanks. Next question. There's actually two questions here. Which blowing agents are currently used to produce PIR and Phenolic? And the second question is, are there any potential changes on the horizon due to any new proposed environmental regulations?
So I will have to look that up. I believe it is a pentane blowing agent. I am not 100% sure of that. There are no current discussions of changing our blowing agents anytime that I know of. But once again, that would be something I would need to contact our Trymer plant manager about and just verify that information with.
And then Lori is asking if you could send out spec sheets, but I think all of those spec sheets, if I'm correct, are listed on the ITW website. And what I can do is post a link to that, to the page on the website in the chat field, so that you can copy that and go and download any spec sheets. So I think that would be under the technical library right on the website. Is that correct?
Yes, so we've got two different links. One will be for the metal, one will be for the insulation, and then you can just click on the appropriate one to get the data sheet that you need. The other option, I believe, is that we might have thumb drives that contain all of those tech data sheets. If somebody wants to have them and doesn't want to do all the downloading, we'd be more than happy to send them to you. I'm more than happy to email them out as people need them. I do that quite frequently as well. So, but yes, they are easily found on our website. Typically it's in a little orange or gray oval button that says technical data sheet on it.
Great. I posted a couple of links in the chat there for everybody. And if you don't see something there or you would like something more specific, email Heather. There's her email address there, and she'd be happy to respond. That's all the questions that we have Heather, thanks again for your time. Just want to remind everybody to be sure to follow Distribution International on LinkedIn. We post updates about upcoming webinars on there. We also post them on our website at distributioninternational.com. Just go to the Resource Center and you will see a link under that tab for our DI 101 webinar series. So I think that'll do it. Heather, thank you so much for your time. Thanks everybody at ITW. Thank you to all of our customers that joined us today and all of our DI associates as well. We look forward to the next one. Thanks, and everybody have a good and safe Halloween. Thanks, everybody.
Thank you.